everyone, and welcome. The topic for this video lesson is, make sure you like and comment so that I know this video was helpful. Also, comment what topics we should cover next. And do me a favor, make sure you ring the subscribe bell. Thanks.
2.1c, prime factorization. Prime factorization is a product of prime numbers. This means that for the number 6, its prime factorization would be 2 times 3. Product just merely means multiplication of the prime numbers that make up the number that we are factoring. To find a prime factorization, we divide by prime numbers. Let's look at this in example 1. Example 1 asks us to find the prime factorization of 360. We will start by using a method called a factor tree. This is where we split this number into two numbers that multiply together to make 360. Since 360 ends in 0, I know that a 2 must divide evenly into it. 2 divides into 360, 180. If you're not sure how many times it goes in, but just that it is evenly divisible, you can go to the side and do a quick long division. To see that it divides in 180 times. We then circle or highlight the prime number and we continue to factor the other number. We see it's also even and 2 goes into 180 90 times. We highlight the prime number and we continue to factor the composite number. It is still even, so we know that 2 goes into it 45 times. We highlight the prime number and we continue to factor the composite number. 45 ends in 5, so we know a 5 goes into it 9 times. We highlight the prime number and we continue to factor the composite number. 9 is 3 times 3. We have now found all of the prime numbers in 360. We can now write them all out in a list, usually going from the smallest to the largest. There are 3 2s, 2 3s, and 1 5. There are more than one digit that are the same, such as 3 2s. We use exponents to show this, and we write it as 2 to the third times, there are 2 3s, so 3 to the second, times there's only 1 5. This is the prime factorization of 360. If we were to multiply these all back together, we will get 360. Let's look at example 2 and a second method of finding the prime factorization. In example 2, it asks us to find the prime factorization of 1224. We'll start by writing 1224. In a division ladder, we start by doing an upside down long division symbol. Then we pick a prime number that will go into 1224. From our divisibility test, we know that 2 divides evenly in because it ends in an even number. 2 goes into 12 6 times, 2 goes into 2 once, and 2 goes into 4 twice. If you're not sure how to divide this in, remember you can always go over to the side and do standard long division. And then write that number underneath. Next, we see it is still an even number, so it divides by 2 again. 2 goes into 6 3 times. 2 goes into 1 0 times. Since it went in 0 times, we actually have to ask 2 goes into 12 6 times. Once again, it is still ends in an even number, so another 2 can be divided in. 2 goes into 3 once. 2 goes into 0, but remember, is it really 0 or was there a remainder from the beginning? So if you're not sure, always go over to the side and do a quick long division. 2 goes into 3 once, but remember, that makes a 10. 2 goes into 10 5 times, and 2 goes into 6 3 times, which means the number here is 153. Next, we see that it's no longer even, so we now have to try the next highest prime number, which would be a 3. Remember, to decide if it's evenly divisible by 3, we add up each of the digits and see if the sum is divisible by 3. 1 plus 5 is 6, 6 plus 3 is 9, and 9 is divisible by 3, so this whole number is divisible by 3. 3 goes into 15 5 times, and 3 goes into 3 once. We now continue factoring. 51 also has a 3 that goes into it, because 5 plus 1 is 6, and 6 is divisible by 3. 3 goes into 5 once, with 2 remaining, which would mean there's actually 21. 3 goes into 21 7 times. 17 is a prime number, and therefore we can go no further. We can highlight each of the prime numbers that we found. If you find any of the numbers you used to divide are not prime numbers, then you have not found the prime factorization. Remember, only divide by prime numbers. We now list them as 2 times 2 times 2 times 3 times 3 times 17. But remember, if there's more than one, we must write them as exponents. So this would be 2 to the third times 3 to the second times 17. We have now found the prime factorization of 1,224. Remember, a prime factorization is a product of primes, or primes multiplied together. And to find the prime factorization, we divide the number by prime numbers that evenly divide into it. And then we list our answer using exponents if there are more than one of the same number listed.